All right, well, thank you all for coming. I recently finished a project where the majority of the project was revolved around configuring remote systems. And when I first joined, there was a lot of manual hands-on time spent spinning up cloud instances in AWS, installing things, running various PowerShell scripts. And the team was very focused on using PowerShell. And so that got me interested to see, what the landscape was for automating computer or server setup. I had kind of joined and doing more of an infrastructure role in which I use a tool called Terraform, but that's kind of tangential to this. But the concept is more so: can we apply the same concepts of taking configuration and defining how we want the system to be set up in code, so that you can reduce the amount of hands-on time you have and the amount of manual touch points. And so that ended up kind of on this topic. So again, the team was heavily invested in using PowerShell. And so I discovered that PowerShell has a computer system management kind of this module already built in, which I had never really used before. So just real quick about me. Again, I work at Inteltech. Here we are hiring, so there's a link to that. There's a link to our other Meetup, the .NET user group, and I think a lot of you are probably already attending that. And yeah, there's my GitHub handle. So I'm pretty sure that we're not actively muting anybody. So as I go, if you have a question, just jump in and ask it. I'd rather answer questions as we're going through the steps. I'll push these slides up. There's a link to where they'll be. It's in a GitHub repo. So if you miss anything, it should all be available. The example code I have is also going to be in that repo. And yeah, if you have any questions or anything after the meeting, feel free to just reach out. I'll do my best to answer it. And I always like to put this disclaimer out that if I happen to say anything kind of provocative about what's good or what's bad or what you should or shouldn't do, don't be offended. It's mostly my opinions, and I don't know all that much. So the Microsoft Docs, I was trying to find a good definition of what desired state configuration is. And this is the most succinct or explanatory kind of sentence I could pick out, which does a decent job, I guess. But really, it more or less, it's using PowerShell and kind of sticking to that ecosystem, the PowerShell ecosystem, to configure computers. But to me, the added benefit is that it provides better syntax. It lets you write less code, and it enables you to kind of set these systems up and spend less time because there's fewer errors. There's less touch points. So this PowerShell here is something I pulled out from that project I mentioned earlier, where there was just tons and tons of PowerShell scripts just getting executed. And the first, kind of thought I had when I look at it is just how unbelievably messy PowerShell can be, which isn't necessarily a fault of PowerShell in and of itself. Code quality and organization and just, I guess, prettiness in general is very subjective. But I would imagine that most people would think this is not the most readable or maintainable code. And so getting away from a place where we're having to write a lot of this type of code is one of the benefits of using DSC and DSC modules. And we'll look at more examples of what DSC actually looks like in a little bit. The kind of next point for me is the amount of effort it takes to just to automate some of the simplest things in PowerShell. So PowerShell has thousands and thousands of built-in functions to manage Windows systems and even more, third-party libraries and such. And while you have the power to do most anything, it doesn't mean it's necessarily going to be the easy or most straightforward process. So this sample code is doing essentially two things. One, it's installing Chocolatey, and the other is it's setting a registry value. And so, I don't even know if this is the best way to check if Chocolatey is installed. I doubt it. But this is a lot of stuff to keep in mind just to install Chocolatey, or just to install anything really. And the same thing for a lot of times when you are configuring a computer, there's going to be a lot of either registry or permissions or just various settings to configure, and having to manage registry keys and define all of those and know all the exact names of the keys to change is hard. It's hard to keep track of, and especially if it changes from Windows versions, it becomes really difficult. So, and again, the code that has the least amount of bugs is the code where there's the least amount of code at all, right? So if we can get rid of lines of code, our lives are going to be so much better. And so kind of on the next point, if PowerShell has all these issues, or potentially has all these issues, why not use a different tool? And that's a completely fair question. So if you're trying to automate the creation of Windows instances, why not use Ansible or Chef or Puppet? And you definitely can. I mean, it's one of those decision points where it really is project specific, and it depends on who the development team is, or whether you're able to take on new dependencies. Are you able to install Ansible, Chef, or Puppet, or whatever else it may be? Does anybody know Ruby, or are you comfortable enough with it? So all these decision points kind of go into the decision process. The interesting thing, though, is most of these tools are actually cross-compatible, which is kind of nice. So if you kind of wanted to get down the road of using DSC or Chef or Puppet, you could kind of go that route and not necessarily waste any of your time or effort, because at least I know that Ansible and Chef, they both have their own resources to deploy DSC configurations. And same thing, there's DSC modules that can apply Ansible. So the various tools out there, they're very feature rich. They all have their various pros and cons. So I guess just consider all the alternatives before you jump completely in. So when it comes down to it, and maybe we'll just take a quick look at a DSC file from the start. What we're trying to do is codify a system, right? Codify the settings of a computer so that we can repeatedly apply that configuration and know that it's going to be built the exact way we want. So here's what we'll be looking at in just a second. And I just want to get this picture in your head. But we're creating this configuration file full of various resources that we'll be applying to a specific computer, which in this case will, in this ecosystem is called a node. So there's, like I said, there's three main components: resources, nodes, and configurations. The resources are really our base building blocks. It could really be anything you want it to be, but some common examples are a single resource would be a single environment variable or a local computer or a local user. But it could be as large as an entire SQL Server database instance, or an Active Directory domain configuration. The scope of it can really vary drastically, but the idea is that it should be at least somewhat isolated, such that you're able to say, does this computer, does this server have this thing, and does that thing that I want have this set of configuration or parameters, right? I want to set up a new computer. Does it have an environment variable for my Azure access keys or my AWS profile? It's a very discrete thing where the system can objectively say, yes, that exists and it has this value, or no, it doesn't, right? A SQL database, again, even though it's a much bigger thing than an environment variable, it's easy to say, does this server have this SQL database? And if so, does that SQL database have this collation that I'm trying to define? Yes or no? And so each individual resource, again, just represents one specific thing that you want to exist on that system. From there, we're defining the nodes. So a node can be anything from just, if you want to configure your own computer in a repeatable way, so you could just specify localhost. If you're on a domain and all the computers on your domain that you want to configure, it could be those. If you don't know the computers ahead of time, that's not a problem either. It could dynamically configure which resources to deploy this to, and so that's really compelling, right? Because it allows you to leverage code and configuration files without necessarily worrying how they get deployed. It's more of you can focus on the concept of the server itself and separate that from the act of having to deploy that configuration. And so just for a quick example, on my Linux or Mac systems, I maintain a repository of .files, which is just a set of various configuration files that I always like to run on a new system. If I have to spin up a new instance, or I get a new laptop, it's already all pre-configured. It's very easy to set up. And so using these DSC configuration files, it's the same thing. I can predefine all of the tools, all of the software pieces, all the environment variables I want, and apply that configuration without having to run a bunch of manual commands individually. But then take that same configuration, and if I want to spin up something in AWS, I could take that same exact configuration file and apply it out there as well. And so, yeah, the third part, again, is configuration. So configurations are really just the incorporation of defining what nodes to apply a set of resources to, right? And so that's where we get to with the actual code part. So finally, we have some code. So the configuration syntax for DSC should look very familiar to PowerShell functions, but they are very different from PowerShell functions. Was there a question? All right. So
no questions. We're good.
Cool. So the syntax is really pretty friendly. So to create a DSC configuration, you use the configuration keyword, and then you could provide really any name you want. The name is pretty much arbitrary, just as if it were a function, right? You can name a function however you want. It doesn't affect the functionality of it, other than it brings it into your, what would it be, like your PowerShell context, right? When you import the module, the named configuration then becomes available. It comes into scope. Again, like a function, you can define a parameter block. And so if you need to configure your resources in a more dynamic way, you can provide parameters at this kind of compilation time. And so in this example, I have a parameter called time zone ID. We may be setting up servers in the East Coast and then servers again in the West Coast. It may be the exact same servers. We just want to change this one little attribute about it. That we want the East Coast servers to be on East Coast time zones, the West Coast servers to be on West Coast time zones, but everything else in the configuration is identical. So when we go to apply this configuration, we're allowing one dynamic parameter so that we can take the same set of resources, right, all the environment variables or whatever programs or whatever other settings that we want, and make this one change at kind of deployment time. And so then for the next main block is our node block. So here I'm just specifying localhost. But this could be any server. It could be IP address or host name. And we're essentially just saying where should this configuration get deployed to? And then within that node, what are my resources? So each resource block is essentially just a PowerShell, a custom object. And it is defined by a well-defined resource name that has to be in scope, and then your logical name, which, like the function, is arbitrary. This is more for kind of for your own benefit or for the configuration itself. It should have some sort of meaning to what this resource represents. And then within that resource block, just the key value pairs that represent the attributes. So every resource is going to have their own set of attributes. So for an environment variable, it's just going to be the name of the environment variable and its value. And then, whatever other specific parameters they may take. Now, a lot of resources have the option to ensure something is either actively present or not present. So if a server ships with some default application or environment variables or system paths or anything like that, you may want to make sure those things don't exist. And so you change this from present to absent to make sure that something is actually removed instead of added. So this resource, this time zone resource down here, I added to kind of show how we are parameterizing one of the attributes of that resource. So here you can see that we pass in the parameter for the time zone ID into our configuration as a whole, and this is where it gets consumed down here as a parameter. The last thing I wanted to point out here is there are times when resources are they have dependencies on each other. So it could be any number of things. You can't, let's say, you can't create a SQL database until the SQL instance has been installed, or you can't, create a database user, a local database user until that user's been created on the system. So DSC has this method of kind of defining resource hierarchy, resource dependencies. And the way that that is defined is by putting the resource type within square brackets, and then the resource name. This is one of the downsides of DSC, in my opinion. The dependencies are all string-based, and you can see how this can be error-prone, right? So these resource names, like I said, they're arbitrary. They really hold no special meaning, other than when you start defining relationships between them. And so making a change to this resource name, there's really no obvious way to know that something else is dependent on it until it goes to deploy and breaks. And so I don't know how you kind of get around that. I think that's just a limitation in PowerShell, really. But for the most part, it's a pretty solid platform. So I showed two resources here, an environment variable resource and this time zone resource. I just listed a handful of modules that exist out on GitHub. There's an entire org or community on GitHub with tons of DSC module groups. And so I listed a handful of the most commonly used resource modules. And I kind of just wanted to go through and kind of show what you can do, what kind of things you can do or control with DSC configuration files. So you can create zip files, again, environment variables. You can manage local groups and local users. You can enable or disable Windows features, right? You can schedule reboots or create schedule tasks, change the UAC controls, manage Windows updates. And this one was really nice because I actually had to go in and set up Microsoft SQL Server. And so some of these modules are very, very full featured. So you can see over here all of the pieces of SQL Server that you can control. So this is really nice, not having to hand tend to, like I mentioned earlier, collations or encoding various SQL logins, setting the SA user and password, replication, all of that stuff. So managing a SQL instance with a few blocks like this is super nice, and it really shines when you have to go and do it the second time, or just make a change and have those changes just instantly reflected in your deployed servers. I also wanted to point out there's this networking module. If you've ever had to manage any networking resources with PowerShell, it seems like there's 6 different ways to do anything. Get network adapter, get network config, all sorts of things. Not having to kind of traverse all of those various objects is super handy. So I think I'm missing a slide here, but the way that DSC, the flow of DSC starts from code. We define this configuration PowerShell module. We build up all of our resources, define our nodes. And from there, we're not actually running this PowerShell directly, right? The code that I showed earlier, this example code here. This can only be run on the system itself, right? Somebody has to either use WinRM or have an SSH connection or copy the script onto the computer itself. And we're actually executing PowerShell directly when we run commands like this. And that's not really a reliable way of managing remote systems. You know, every system potentially is set up differently, especially if it's already been bootstrapped in the past, and the likelihood of any of these steps failing is higher than it should be. And so instead, we're taking our configuration files and we're more or less compiling them, if you will. And the way that happens is it takes our configured nodes, our configured parameters, and all the resources we've defined, and merges them together and creates a more logical representation of this setup and saves it as a file called an MOF file. I forget exactly what that stands for, but that file, and we'll look at an example of it when we do the live demo. That file has the entire configuration in one well-structured kind of hierarchy. Then each system is responsible for managing it and for deploying. And that's what ends up getting sent back and forth between these servers. So we're not sending PowerShell over the wire. We're not telling a system to run any specific PowerShell. We're saying we have this well-defined kind of middle language for a DSC model, and I want you to run it. You execute it and make sure that happens. And so there's two kind of deployment models that we have. You can either have a central server push out configurations to the systems that you want to manage, or you can have those systems reach out and pull as they think are needed. So in the push model, if you could think of it in terms of, you know, maybe thank you, managed object format. Thanks, Reese. So if you can imagine you don't have any build pipelines or CI/CD set up, you know, you are working on your local computer, you have a server farm of 10 SharePoint servers somewhere. And so you know that you want to make some update to all of those servers. You can update your local copy of your configuration. And then when you go and compile that configuration, it'll push it out to all of your configured servers. So that's the first method, and that's the easier method to get started with DSC. The second is a pull-based model, where it involves a little bit more setup, but it's a bit more resilient. And in the pull-based model, all of your servers that you're trying to manage are configured to phone home every once in a while to check in and see, are there any updates that I need? Has the configuration changed? And if so, they'll reach out to the configuration server pull down the latest changes of the configuration file, and then apply them to themselves. So we're going to jump in and do a little bit of a live demo here, hopefully. And so not too much. We'll just stick with this. So getting started with DSC is really easy. So I have this setup script that I ran. This is a fresh instance of Windows 2019. And really, I'm just installing a handful of PowerShell modules. This is actually more than I needed. But PowerShell, because PowerShell already comes with the core kind of infrastructure set up to handle DSC out of the box, there's really not much in the way of setup to get this started. So whether it is the server that you're trying to run locally, or a central management server, or any a handful of servers in your server farm that you want to configure, they're already set up to do DSC out of the box. And we kind of touched on this earlier. It's really compelling because I don't have to then go touch all the servers to set up Chef or Ansible or have agents on any of those machines. They're already ready to go. And yeah, so there are a handful of resources that are built in to PowerShell already. But for the majority of the things that are actually worthwhile or that you'll find yourself using, it will just be importing one of the modules that we've kind of looked at up here.
Steve, does that import happen automatically, or do you have to do this install step on the server? And can you do it via DSC? If so,
I'll have to verify for the push-pull model if those servers have to install the modules. I don't think they do. So in this case, I'm running. It's not really the push or pull model. We're running. We're going to build a configuration for our own computer, and we're going to apply it on our own computer. And so because of that, we have to make sure that we have those modules installed.
okay.
Because we're both the source and destination, right?
Yep.
We can't have it not installed. Something has to have it installed.
Yep.
So if we were using I think if we were using a push or pull based model, in either of those cases, the configuration server, the thing that is generating our configuration files, that at least has to have all of the modules installed.
Yep.
But yeah, in this case, because we're just running it locally, I had to go ahead and install these modules because yeah, then they just don't exist anywhere. And so this is an example configuration file, right? Much like we already saw. In this case, I'm just generating this for localhost, right? I don't want this configuration file to be pushed out to any other server. I just want it to save it locally on my computer. And what are we going to do? We're going to set an environment variable. We're going to update our time zone because this is in I don't know what time zone this is. Minus 6 hours. So, and then we're going to do something that we haven't seen before. We're going to loop over some configuration data and apply this registry resource dynamically, right? So we don't have to specify every single resource that we want up front. We may not know that. If we had to specify every registry key and value as a separate resource in the configuration file, it gets very, very tedious. And you know, again, we're back to kind of the initial place with our original PowerShell files, where we're manually having to go in and define. Let's see. There it is. Right. This is gross. And if we have to have 6 lines of code to define every registry key, it's kind of a nightmare situation for maintainability. So in this case, we're looping over some variable, and I'll show you where that variable comes into play. Ultimately, it doesn't matter. The fact is just that I know that I want to define some set of registry keys and values, and there's a list of them, and go ahead and add those. Here is our some Windows update settings, which I'm going to not run on this first loop because it takes a long time and it requires rebooting, all that stuff. But we will get back to that. And then just a handful of other settings. So changing some Internet Explorer settings. You know, the first time you start a new server, you go to use Internet Explorer, it's always popping up with the various security prompts. So getting that configuration out of the way, doing bad stuff with user account control configurations, disabling a bunch of stuff because we know better as power users. Enabling remote desktop administration, adding OpenSSH server to our instance. So here's just a handful of things that you know a basic Windows Server install might do. So, like I said, we're getting this data in for a bunch of registry keys. We're looping over it, but we don't have a parameter for it. So where is this magic data coming from? So there's a secondary method of providing data to our DSC resources, and I love this capability because having to pass parameters in to a configuration kind of breaks the spirit of what we're trying to achieve as far as putting all of our configuration in code, right? We can't codify, you know, if we're trying to deploy this configuration out to the East Coast, Central, West Coast, then those end up being essentially runtime parameters that we would put into our build server. And maybe that's fine. But the other way of handling that is using a PowerShell data file, so a PSD file, right? And there's some common functionality, some common key values that are required for DSC. But other than that, you're essentially free to list out any settings that you want, however you want to use them. It's essentially a giant hash table, right? So now you can see where I'm getting my registry keys and values from, right? So I'm going to loop over this array of registry entries, right? Pull out the key, and then again, I have another list of key value pairs to place under each of those registry paths, right? And so there's some magic variables that exist that you can use within the configuration block. The main one is called configuration data. right? So this is a kind of a built-in parameter that's supplied to your configuration. This configuration data is going to end up being whatever you supply to the configuration at quote compilation time. For our specific purposes, you can assume it's this data. And so I have a key for time zone ID. I have a key for registry. And I'm able to pull it out like this. On top of that, you could define node-specific values, right? So here I have a key for all nodes. You could imagine I have a key for East Coast nodes where I have a different time zone ID for East Coast, for West Coast. And so then I'm able to codify even all of my separate parameters if I want. And then in my configuration, if we wanted, we could specify some custom logic in here to test what kind of node it is, to change what the time zone ID stuff like that. Okay, so we've seen a configuration file. We've seen a data file. So how do we actually do something with this? And it's really just a handful of built-in DSC PowerShell commands. So like I said, there's two steps. There is the compilation of our configuration and then the application of that configuration file. So I'm going to go ahead and run this, and then we'll talk about what's happening. Hopefully it works. So you can see it. Oh no. Error. So the first step we have to do is, because it's still PowerShell, our configuration is still in a PowerShell file, we have to pull it into scope. So what I'm doing here is importing. This is demo.psm1 file. Okay. So now I have access to my configuration. Then I want to apply my configuration data. So I import my PowerShell data file. And just as if I had imported a function from a module, my configuration, dependent on the name that I gave it, is now in scope, right? So demo configuration is now in scope. So I can provide it the special key called configuration data, which in this case is our hash table that we defined in here. We give it an output path, and this is essentially the output for the MOF file that we're generating. And then the last part is to actually, apply that configuration. And so we tell DSC, right, the DSC machinery to, to run the configuration at whatever this path is. So let's set that. Might just have to reload. I always forget how to clear out my session in ISC. So the MOF file, so let's take a look at that. So again, this is the first step of the process. We take the configuration, we take our parameters, we take the PowerShell data file, and this is what we're generating, right? So this isn't really PowerShell, but it's this custom kind of format that can be used across systems, right? It is a contract that can be specified. It can be implemented outside of PowerShell itself, and that's one of the reasons why I don't know if I had already mentioned this. A lot of this can work across PowerShell 5, 6, 7, Windows, PowerShell, Linux systems, because they're built for the contract, not necessarily the target version of PowerShell itself. And so you can see, in our configuration, we just had time zone ID specified, but now you can see that because it was parameterized, the MOF file that's generated has the values injected into it. Our configuration file had this loop of unknown number of registry keys. We just know that we were looping over something. The compiled configuration has a block for each of our registry keys. And that's, I think, so yeah, so then this, if it's a push-based model, this would get pushed onto our remote server. If it was a pull-based model, this would get compiled at really any time. The pull server is asking the configuration server, have you made any updates to your configuration? If so, go ahead and send me that data. And then I can apply it. So this is running. The system's running right now. And you can see that my time zone is now Pacific time, based off of what we've configured. And so each of these resources is going through 3 phases, right? Because as part of configuration management, you want these things to be idempotent, right? Running bespoke PowerShell scripts where you're making changes, trying to install things, they're not idempotent by default. Unless you're going and constantly checking whether something's been installed and writing all of that code into your PowerShell script, then the chances of you running that script and then running it again tomorrow or even minutes later and having it break are high. So for each of these resources, it'll go through 3 stages. The first is, give me the current state of this resource for this computer. Then test whether or not that state matches what I would expect that state to be as defined in our compiled MOF file. If it passes, then it won't do anything. If the system says they're not in sync, then it'll run the third stage of the resource of setting or updating the state for the resource, right? So if I was to I can just run this. So if I was to run this again, right, we're not recompiling anything. We're just trying to process the MOF file that's already been created. In theory, nothing should happen. Everything should already be in the correct state. It's going to go through, it's going to check, but this process should be very fast, okay? If I was to go in and let's go ahead and make a change. We updated our time zone. If I run it again, we should see our system go through the test phase. And again, yeah, they changed it right back. And so, right, I'm applying the same script, the same file over and over again, and nothing's blowing up because it's built in with this capability of knowing, well, where am I? Is this right? Is this not right? And is there any work to do? If, let's see, if I open up. Well, this works, Easter. Let's try it. I don't know. So I'm not going to try to figure out what other time zones are accurate, but the point being that the system is very resilient. It's all data driven. It's all configuration driven. It's all in code. And because of that, it can go through the same rigorous processes that we put all of our other code through, right? Pull requests, code reviews, testing to some degree. Because one of the other nice things about this is it's very easy to build your own custom resources. Right? There's pre-built resources to handle almost every need that you have. But when there's not, creating one is a very simple process of making a class in PowerShell with essentially just three methods to get, set, or test the state of whatever it is you may want to be applied to your environment. So that's all I have. Again, this is hopefully just kind of a good introduction and just providing some visibility into this system, which, you know, as I got into it, a lot of people who I talked to hadn't either heard of it or had never used it, and it's actually quite powerful. And having it built into the entire Microsoft ecosystem already is really nice. If you're using Azure, because I didn't have any first-hand experience with Azure, otherwise I would have shown it in action being deployed out to Azure instances. But Azure has built-in functionality through Azure itself to take DSC configurations and apply them to instances in the Azure ecosystem. So if you're working in Azure, if you're deploying instances out there, I would highly recommend looking into using DSC to manage those. So yeah, are there any questions?
Yeah, I have a quick question, if that's okay. I'm not really familiar with this technology, so forgive me if this question makes absolutely no sense. But I was curious in regards to, so I don't know if you're familiar with SCCM, but I was curious if this could be used hand in hand with SCCM in terms of kind of improving upon the base scripts that SCCM kind of works off of, as this can be fairly slow and clunky. And I haven't used it a lot, so I've only used it for a few things in a previous job. Or if you think that DSC is something that would entirely replace SCCM, or if they have their own two areas in managing.
I'm not familiar with is it SSCM or SCCM?
System Center Configuration Manager. So System Center Configuration Manager, SCCM.
Oh, sorry, I was saying it wrong then.
No, that's all right.
I haven't touched it in a couple years.
I thought you were saying it right, so I was just explaining it to Steve. So
yeah, I don't know. I would have to look into that.
Okay, yeah, it's something I'd be curious about because it seems like this would benefit people who use that software, as it's like it's definitely it's got a lot of big use cases and it's a paid for software, so it wouldn't be something that they'd want to replace, but it's definitely slow and clunky and terrible to use. So this seems like it would be something that would improve upon it.
I think for sure. And then there's other. It's the same sort of thing, but there's a lot of stuff that goes along for the ride with SCCM with regards to reporting and managing, thousands of machines. Let's say what are all the configuration? But there is a lot of similarities. An SCCM is you can think of it as agent based, but it's managing Windows machines. So I believe most of what it needs is already installed on a Windows machine, kind of like DSC. So, but I'm far from a sorry, I can't even say it right. SCCM expert. So, but definitely similar concepts. I don't know if they picked up any of the stuff or they, because DSC, although it's been around a while, it hasn't been around as long as SCCM, which is sort of a legacy product now as well with Azure. There's Microsoft. There's still legacy, but it's primarily an on-prem technology, and it's been replaced with or is being superseded in a different way with some Azure technologies. Azure Monitor and whatever they've gone through a couple of different name changes, so it's hard to track the exact legacy, but in any event, this is cool stuff, Steve, and you did a good, really nice job of doing a nice intro, way better than the Microsoft docs, so good job.
I just real quick, I wanted to just show you what, if you wanted to create your own custom resource, I just wanted to show how easy it is to do that. So there are a handful of different ways to make them, and I'll let the docs kind of differentiate those. The easiest for me was just to create a class in PowerShell that you decorate with this DSC resource attribute. The properties are defined as class properties decorated by a DSC property attribute, right? And so here I have object key. So the resource I wanted to create, I wanted to automatically provision these servers. So my use case, I needed to install software. That software had to have a license. So I had the license file saved in an S3 bucket, right? And there is no DSC resource, for an AWS S3 file. So I created a simple class that takes in an S3 bucket name, the key for the file within that bucket, where that file should go. So these are the 3 required parameters that I need. And like I said, at minimum, all I have to do is define 3 methods: get, set, and test. Okay. And so in my get method, I'm just returning the instance of the class itself, which has already been instantiated by the DSC framework. And really, this method just allows you to supplement attributes that the user is not providing. So I've defined 3 attributes the user has to provide. I have a 4th attribute that the user is not able to provide. So I put creation time just as an easy way to know when that file was downloaded. When it does the get evaluation, I just check, do I have this file? If I do, let's go ahead and populate the data which it was created, and we'll spit that back out. And so if you go to get information about your resources, or you're trying to get debug information, we'd be able to see this property in addition to the others. The real magic comes in set and test. So test is essentially the important thing. You return true if you're in the right state. You return false if you're not. I have delegated that functionality to a different method, since my get also uses the same logic. But you can really put your hardened PowerShell scripting code in here to test whatever your state is. And this is especially useful if you're doing the same thing over and over again, or you're using it across different configurations. Instead of creating PowerShell modules that you maintain locally and all of that stuff, you can put all that logic in DSC resources, and it really helps to clean things up quite a bit, because you're not relying on having your PowerShell module paths or anything like that be set up properly. This code is much more testable than having a kind of a utility module with a bunch of random functions in it, because it's kind of this is a Linux type principle, right? Do one thing, do it well. Have this file, this one self-contained thing, be responsible for this one specific resource, and keep all that functionality together. So this is checking, hey, is the user's path that they provided me, it does all these additional things just to make sure that when I run this over and over again, or on any number of systems and any sort of configuration, that I can recover, or I can that I can always be in a good state. So if I'm trying to download a file, but there's a directory that already exists with that name, or any number of things, I can account for that. And so in this class, I'm just testing, do I have this file path that you told me about? If not, then return false. If the file path is already there, then I assume I've already downloaded the file out of S3. And then how does that happen? It happens in the set. So if we tell DSC false in our test method, then the set method gets invoked. And then I'll reach out to S3, download the file, save it to the destination that was provided, and then that's it. So this is much more verbose than it really needs to be, right? So it's 72 lines of PowerShell. It could probably even be 35, 40 lines if I wanted, and you could have it tailored to any of your needs. And so Meg, back to your question, even if it didn't play nicely with a CCM, if you needed if you absolutely had to and you wanted to wrap that functionality, creating a few classes, a few resources wouldn't be a too terrible thing to do.
Yeah, thank you. This is really cool.
I'll include this example too in that repo that I'll push up hopefully tonight.
Once you create like a custom resource like this, do you have to install it like a module somehow, or?
Yeah, it depends on how you want to use it. If the resource is with your configuration code, you can reference it directly. I'm pretty sure. If you want to, let me pull up the PowerShell module format. The manifest has a key for DSC resources. DSC resources to export. So if you wanted to make a module out of your DSC resources that you would then import somewhere else, you would just make a PowerShell, you'd include those files like any other PowerShell module would. But instead of listing out this class as like a function to export, you'd include it in your DSC resources to export.
Okay, thanks.
And then in your configuration, so if it was in a separate module, within your configuration block, so make sure that these resources are in scope. So even you have to invoke this import DSC resource argument or command. Now these are modules, right? And if you were writing any other PowerShell and you wanted to bring functionality into scope, you do import module and give it the name. And technically, these I think would work by calling import module. The difference here is that the way the scope is invoked is much different. The way the code gets set up is much different. Because this is within your configuration block, right? We're not actually trying to import things on the system where we're running this. We're trying to tell the configuration that, hey, when you run this stuff on this node, you're going to need to import and have this stuff in scope, right? And make sure that it gets included into your MOF file and all of that.
Awesome.
Thank you. Any other questions? Yeah. And if any of you end up testing this out or trying it out, and you have questions or run into any issues, I'm always available. Shoot me an email. We can hop on a call, or I can try to help you troubleshoot or anything like that.
Awesome. Thank you, man.
Yep.
Okay. We'll call it good. And then for tonight, and as always, on the Meetup, Twitter, email, whatever, feedback, welcome, appreciated. And if somebody has an idea for something we want to cover the next time, do let us know, or you want to present, let us know. Thank you.
Thank you all. Thank you for attending.
Thanks.